Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the binary adders and subtractor. That is a common circuit which can be used as a 4-bit binary parallel adder as well subtractor. Before going into the circuit of 4-bit binary parallel adder slash subtractor, let us quickly review 4-bit binary parallel adder and 4-bit parallel subtractor. The topic is from the unit Combinational Logic Circuit. The subject name is Digital Electronics. Okay. So, we need binary parallel adders when the two binary numbers A and B are having more than 1 bit. Okay. So, as it is a 4-bit binary parallel adder, we need two binary numbers comprising each of 4 bits. The binary number A is comprising of bits A3, A2, A1, A0 and binary number B is comprising of bits B3, B2, B1, B0. So, the parallel adder is used to add two binary numbers A plus B. So, this circuit which we have already seen in the previous class, the 4-bit parallel adder requires 4 full adders. Full adder is having 3 inputs, input A, B along with the carry. Initially the carry input is 0 for the parallel adder, that is the carry is 0 for initially addition. So, the first full adder is having the input C in 0, A0, B0, the output is S0 and C out, carry out. This is all about the first adder. Now, coming to the second full adder, it is having two inputs A1, B1 with the carry input C in. The output for this full adder is S1, sum and carry C out. Now, coming to the third full adder, the input for this third full adder is A2, B2 and carry input C in. What is C in? Whatever is a C out, that will act as a input carry to this full adder, and the output is sum S2 and carry C out. Coming to the fourth full adder, the inputs are A3, B3 with input carry C in. So, these three are the inputs and the output is sum S3 and carry C out. So, this is a 4-bit parallel adder circuit. Okay. Now, coming to 4-bit parallel subtractor. Here for 4-bit parallel subtractor we need 4 full adders, 1, 2, 3, 4, 4 full adders we are requiring. Here in subtraction we are doing subtraction of A minus B, and A is comprising of binary number A is comprising of 4 bits A3, A2, A1, A0 and binary number B is comprising of bits B3, B2, B1, B0. When we do subtraction A minus B, we find the 2's complement of B. How do we find 2's complement? First we find the 1's complement of B. 1's complement is done by using NOT gate and adding 1 to it to become 2's complement. By adding 1 to the least significant bit, it becomes 2's complement, and the result of 2's complement of B is then added to A. So, we need a full adder. So, the first full adder, the input is A0 and the input B0 is given through a NOT gate to get the 1's complement, and then the input carry is 1. So, what happens? By this you get the 2's complement of B0 which is getting added to A0 to get the sum S0 and output carry C out. So, for this first full adder the input is C in is 1, A0, B0 is given through the NOT gate to get the two outputs sum S0 and C out. The next full adder is having the inputs A1, B1, C in, these three are the inputs, and the output is sum S1 and C out. The third full adder is the 3 inputs A2, B2 is given through a NOT gate and the input carry. So, these 3 are the inputs and the output is sum S2 and carry C out. For the fourth full adder, the inputs are A3, B3 is given through a NOT gate, input C in, carry in. So, these three are the inputs and the sum is S3 and carry C out. So, we need 4 full adders, and here initially the carry input must be set to 1. In full adder, the carry input is set to 0. In subtractor, the carry input is set to be 1, because we need to find the 2's complement of B. So, once you are clear with the adder circuit and the subtractor circuit, binary subtractor circuit, now we can design a common circuit which can act as a subtractor as well as adder. So, the next topic is 4-bit parallel adder oblique subtractor. That means a common circuit which can act both as a adder as well as a subtractor. So, we are designing a 4-bit parallel adder. So, we need 4 full adders, 1, 2, 3, 4, and full adder is having 3 inputs, A, B, carry. Output is sum and carry, C out. So, here when we are using a common circuit, to the B input we are connecting a XOR gate. One input of the XOR gate is connected to B0, B1, B2, B3. Another input of XOR gate is connected to the control input. So, M is known as the control input, mode input. This mode input will control the circuit, whether it will be used as an adder or a subtractor, this control input M. And this control input is also connected to the carry input of the first full adder. So, when we want to use it as an adder circuit, so input should be how much? 0. So, we can set M as 0. So, when M is 0, what happens? The carry input comes here as 0. Carry input is 0, A0 is coming, A0 is coming, and here it is B0 through an XOR gate. So, here what is output? M is set is 0, so it will become 0. So, B XOR 0 is how much? B XOR 0 is B. What is B XOR 0? B dot 0 bar plus B bar dot 0. So, B dot 1 plus 0, that will come as B. So, B XOR 0 will come as B and B XOR 1 will come as B bar. Okay. So, here the mode input is 0 now. So, B XOR 0, what it will come here? B naught. It will come as B naught. So, here the inputs are A0, B0, input is 0. Okay. So, what it will do? It will act as an adder circuit. So, here M input is given. So, B1 XOR 0, B1, B2 XOR 0, B2, B3 XOR 0, B3. So, likewise we are getting the inputs A3, B3, A2, B2, A1, B1, A0, B0 with input carry 0. Now, this circuit works as an adder circuit when the control input M is 0. Now, let us make this control input 1. So, what will happen when the control input is 1? This 1 will come to all the XOR gates. So, B XOR 1 will be B0 bar. So, what are the inputs here now? A0, B0 bar, A1, B1 bar, A2, B2 bar, A3, B3 bar, and input here is 1. So, it will act as a subtractor circuit. So, depending on this control input, we can use this circuit as a 4-bit parallel adder or a subtractor. So, you need to remember here one point: B XOR 0 is B, B XOR 1 is B bar. Okay. So, the mode input controls the operation of the circuit. When M is equal to 0, the circuit is an adder. When M is equal to 1, the circuit is a subtractor. So, M is equal to 0, input carry becomes 0, the full adder receives the input from the XOR gate as B. When M is 1, the input carry is 1, the full adder receives the output of the XOR will be as B bar. So, it will act as a subtractor circuit. I hope the circuit is clear for 4-bit parallel adder and subtractor. If you have any queries, you can post in the comment section. Thank you. Good luck, students.